So let's kind of pick up a little bit where we were last time, and in particular, what I definitely want to hit today is how to do input with stuff. So let me just start up, well, let me start a new folder for this in VS Code. And the first thing I want to do is just remind you guys how you did this in Python, mostly to contrast with how it works in C. So let's make a new folder. We'll call this input, and then let's get VS Code open. And it'll throw a bunch of errors at me because I haven't reconfigured everything correctly. All right, so let's make a new file, and I'll just do Python for this one. Okay, so we'll call this input.py. And all right, so how did you do, and we'll install those stuff, and I'll configure all this crap later. How did you do input in Python, right? So if I wanted to prompt the user for some sort of input, what did I do? Yeah, so some sort of variable name for it. So let's call this user input, whatever, okay, equals, and then it was input of, and then you could give them a string, which would say, please type something, whatever, and then that was it, right? No semicolon, because this is Python. Okay, and then I could print, so there's two things I want to print here. I want to print the type of the object user input, and then just for giggles, let's just print the user's input. Okay, why is my keyboard being laggy? There we go. Print whatever they typed back to us. All right, let's save that, and let's see, this was in the input folder, and so Python 3 input.py. Okay, great. So nothing particularly special there. You guys probably use this a lot in 111 for various things, okay? But in particular, what I want to observe is when you define this user input as the variable that is going to basically take the data that the user types in Python, what is that data type always? It's always a string, period, end of statement, okay? And if you wanted the user to type in a number, for example, you then have to do a type conversion from that string. So like if you wanted them to type in a number and they typed in 3141, well, that's a string that contains the characters 3141, not the actual numeric value 3141. So if you wanted to use that number as a number for arithmetic or whatever, then you'd have to convert the string into either an int or a float, depending on what you wanted to do with it, and then do stuff, right? But you couldn't just automatically do that, okay? Nor can you specify to input what kind of data that you want to come in, okay? Now, contrast this with C. You can specify the type of data that you want to come in, okay, using the scanf function. But the what you're passing to it is a little bit different, okay? And whether or not the scanf, what it returns is different. So it doesn't return the object, but rather a pointer to it in most cases. Okay, so makes sense with Python? Yeah, I mean, you guys have all done that. The other thing, of course, is that the input method, if I put something inside of it, I'm pass it a string. That's a string that prompts the user. If we want to do that in C, we have to print something and then ask for input. So it's a two-step process rather than kind of one like it is in Python. Okay, so no big deal there? Yeah? Okay, excellent. So let's do a new program. Okay, and let's just accept as input some various things. Okay, so first thing we need, of course, standard input output, and we'll probably need the string for something in a minute. All right, int main void, and okay, so in order for me to accept input, okay, there are two methods or two functions that we can use to accept input. One of them is if you just want to accept a single character, and that one's getChar, okay? And not always are you going to need that one, because, I mean, how often do you need to type a single letter, right? Not super often. The other one, Scanf, is going to be the one that we use more substantially. Okay, so before I do anything, I need to allocate data or a variable to store the data that's going to come in from this function. Okay, and for sake of example, let me actually do it twice. We'll accept numeric input and we'll also accept string input. Okay, so we'll do two separate instances of it. Okay, so I'll allocate data space for some sort of integer. And by the way, is the screen, like, is this sufficiently readable and the font's big enough and whatnot? Okay. If it ever isn't, just let me know, please, so I can adjust it. And does this color scheme and stuff, when you guys look at the recordings, is it sufficiently visible and everything? It's easy to read? Okay, good. So this is sort of one of the things about streaming that is different than making YouTube content. Like, you know, like, does anybody watch like some of the big tech YouTubers like Linus Tech Tips or yeah, some of the, or Marquise Brownlee or huh? Yeah. So yeah. Anyway, these big YouTube channels. So the thing that's sort of weird for me is, like, they do all of that stuff without an audience, right? And that just feels weird. You know, as a teacher, right, I'm used to having a room full of people. So anyway, okay, so I'm going to allocate space for a number, and then and we'll use a numeric input for one, and then we'll also do some sort of a string input for the other. So we need to allocate space for the string. So how do I do that? How do I allocate a string? What data type? Not just string. What is a string? It's an array of characters, right? So car, and then my string, and then how many letters or characters are we going to permit here? Well, we really should define some sort of number here, um, as sort of a limit on how many characters we'll accept as input. Um, and this number can be somewhat arbitrary. I'll just pick 16 for the sake of demonstration. Um, and so that will allocate for us 16 bytes to hold the the string's data. Okay. So something like 16, 32, you know, roughly in that ballpark, is sufficient, um, and just needs to be something. And we should probably allocate that number in advance rather than just taking any old data that the user gives us, because how do we know that they're not going to give us a gigabyte worth of string, right, or something crazy? Okay. All right. So anyway, now the number and the string, I've basically initialized a space in memory to store them, but I've not initialized a value to them. Okay, so right now they're basically just empty objects. Okay, so let's accept the number first. Okay, and so to do that, let's first prompt the user. Okay, to type something, and then we'll actually accept the input. So I'll do scanf. Okay, and for reasons that'll become clear in a moment, I'm actually going to define another integer, and I'll call this success1. Okay, and then for scanf, like printf, what do I have to pass printf to print anything? Huh? Uh, the data type, the first thing is I need to pass it a format string. Okay, and the format string is kind of what specifies the types of data, possibly if I'm printing a whole bunch of things. But at minimum, I have to pass it a format string. Okay, what kind of data do I want to accept from the user first? Let's start with the integer. Okay, so what's the format string for an integer? Just %i or %d, either way. If you make it %x, by the way, they could type it in hexadecimal, which could be useful in some situations. Okay, importantly, because this can cause bugs later, notice that I put the carriage return, so the \n, in the print statement, but not in the scanf statement. If you put it in the scanf statement, I've found that you get weird behavior sometimes, so don't put it there, okay? All right, so good? Yeah? Okay, so let's do a couple of things here. Let's print back what the user gave us, okay? So we'll just reprint basically what the user typed, and then we'll also return whatever the success value is, okay? And so what is it? The number was um, oh, okay. I'm sorry, I forgot one other thing. Um, so let's see, it was my number and success1. Okay. So, and let me scooch this a little bit so you guys can see it. Okay, now I have one error here because I did forget something, um, which is you have to pass two things to scanf: what kind of data you're accepting, and where are you going to put it. Okay, so where am I going to put this data? Well, that's the no, it's not success1, right? That's what it would look like if this were in the Python syntax. Okay, what I have to give it is a pointer to where to put that data. Okay, which is the name of a variable basically. Okay, so in this case, I need to do the pointer to my number. Okay. All right, so let me elaborate on that in just a moment. Okay, but first off, let's, oh, and I need a semicolon here, and that should be good. Okay, so let's compile and run this real quick. Okay, and then run it. Okay, so please type a number. It's asking me to type something, okay? And let me type 1832, okay? All right, so, oh, and let me put a carriage return here real quick just for cleanliness, just so it's easier to read. Okay, so what did I do? What did I give the scanf function? I had to give it a format string that said what kind of data I was going to be accepting, and I had to give it the location in memory where I wanted to put the data that it got in. Okay, so two things. Now in Python, you didn't have to worry about the locations in memory. Okay, so what's the difference between my number and then my number that has the ampersand in front of it? Okay, what is my number with no decorations? Huh? After the scanf runs, yes, it is 1832. Okay, but it's an integer of some sort, right? And in this case, since I typed 1832, that's what got put there in memory for it. What is ampersand my number? It's not 1832. Okay, my number is 1832, but ampersand my number is the location where that thing is being stored in memory. Okay, what do we call the a location in memory, right? So this is the mailbox analogy that I think we talked about last time. No, it's not a register. You store that data in a register, but the ampersand is the mailbox number. It's saying, okay, whose mailbox has 1832 in it? 1832 is the thing in the mailbox. Ampersand 1832 is the thing that points, hey, it's that mailbox over there. Okay, does that distinction make sense? Oh, you guys are going to become experts at pointers by the time I'm done with you this week. But yeah, pointers, by the way, are the thing that drives every C++ student crazy, or C student crazy. So yeah, buckle your seatbelts. Yes, man. At the moment, nothing. Well, okay, actually, all it does is it allocates space in memory for a string of 16 characters, but we're not using that for anything yet. We will in a moment. Okay, so scanf, you need to pass it the format string for what kind of data you're accepting, okay, and that can be a character, it can be a string, it can be a number, meaning an integer, it could be a float, it could be a long, it could be a double, right, whatever, and you use the same format strings for that you would with printing, okay? So here, %I means what kind of data am I taking in? An integer, but specifically a 32-bit integer, okay? If I wanted to take in a 64-bit integer, then I would have had to use what for my format string? %li for long integer, okay? And then up here where I declare my number, I would have had to have declared this as a long int instead of just an int. Okay, the 32 versus 64-bit distinction for what we're doing in C is not horribly important, but it will be deadly important when we get into the assembly, okay, for reasons that we'll see later. Okay, now, the last thing that I haven't really explained yet is what is this variable called success1? Okay, I called it success1 because I'm going to have another one for the next scanf in a minute. But scanf returned the value 1. What did I tell scanf is the type of data I wanted it to accept? An integer, right? So that's what data, what did I tell scanf I wanted? An integer. What did I type? An integer, okay? And this return value tells me whether or not the data that was accepted or typed by the user matched the data type as to what I told scanf to expect. Okay, now let's say that I'm a moron, okay, and I type ASDF where I told scanf to expect an integer, okay? Well, first off, the input value is 0, okay, and the reason that happened is because I gave scanf ASDF. Can it put that in memory where that int is? No, it's not an int. So it doesn't. and therefore that integer stays in its sort of default state, which is 0 basically for anything. And then scanf returns to me what value? It returns 0 to tell me the user's input did not match the format string that you gave me. Okay, meaning the user typed gave me garbage. Okay, does that make sense? And if I do it again and type, say, numeric data, but, right, then it sort of works, okay? But what happened with the period here? It just truncated it, okay? And only took it as an integer, okay? So here, at least it sort of matched. It wasn't a float, it was an integer, okay? The reason for that is, well, we'll talk about that more later. But if I wanted a float, I should have said %f for float, right? And then I would have to redefine this to be a float rather than an integer. Okay, so this return value can sort of help you with input validation, not completely, but sort of. Okay. Okay, so there I accepted an integer. Let's do the same thing for a string. Okay, so printf, please type a string. Okay, and a semicolon. Okay, and I'll do success2 equals, oh, and I should define that variable up here. Equals scanf. Okay, what type of data do I want to accept now? A string, okay? And where am I going to put this in memory? Well, where I allocated it, okay, which is my string. Oh, and I need quotes right there and there. Okay, so format string and location in memory where it's going to go. I'll elaborate on that in just a second. And then let's oops. And I want a \n and a string and, or not string, it was my string. And then I wanted success2. Okay. Oh, and then I need a semicolon, I think. And okay, should be good there. Let me scoochy this a little bit more. Okay, so what kind of data do I want this time? I want a string, so I'm going to tell it I want a string, and where is the string in memory? Yeah, okay, now, this is one of the things that's sort of annoying about C. I should put an ampersand in front of it, okay? But for strings and arrays, the name of the variable is equivalent to the pointer. Okay, so you don't have to put the ampersand with strings or arrays because the string's name is already a pointer. Okay, and that's maybe a little confusing. I wish it were maybe a tad more consistent, but sorry. Okay, and then why did I put the / quotes here? Okay, what happens if I put quotes in a format string? It thinks it's the end of the string. Okay, and so if I want to actually print quotes within a string, I have to use the / quote. It's kind of like, how do I make a line break at the end of a string or printing? I have to put \n, so a control character. Yeah, okay, so that's all I got to do there. And then let's compile it and make sure I didn't screw anything up. All right, so please type a number, 1832. Okay, please type a string, ASDF, okay, and ASDF's returned 1. Now, if I do, what about if I did this? Okay, what's the difference between the 1832, the first 1832, and the second 1832? Yeah. First one is an integer, and the second one is a string that contains the characters 1832. Okay, so do you guys see the distinction between those data types? Yeah? Okay. And if you, well, one of the programs that you guys will write eventually, we'll talk about it later, is did you have to do this in Python where you accept a string and then you convert it to an integer? Okay. But is there a function that just does that for you in Python? So if I typed a string 1832, could I do int of it and bam, I'd magically have an integer? Did you guys ever have to write a function that would actually do that? Or did you just like use the magic built-in function? Oh, well, that's not good enough anymore. Okay. So yes, you guys will end up writing your own string to int function and you will love it. It's so much fun. Yeah? It's not too late to drop the class. No, I'm kidding. Okay. So, right. So the difference is here, string versus integer. Okay. Now, let me do one other thing here just for sake of demonstration. Okay. I'm going to recompile this and I'm going to add the static flag and the -G flag. Okay. And the reason I want to do that, the G for debugging, because we're going to go into a debugger, and the static basically just so that the printf doesn't cause problems with the debugger. Long story, but just do it, okay, for this. All right, so I'm going to do that, and then to make this a little easier to see, I'm going to open up a new, completely large terminal window. All right, and let's go to programming and input, and then I'm going to do GDB and then the name of my executable. And then I'm going to do break, main, and put a breakpoint, and then I'm going to start running it. And okay, so so what is it about to do? It's about to print, please type a number. Okay, all right, so it asked me to type a number. There it's asking me to type the number, okay? And the command it just executed right after I did that was the scanf. So that was me just typing the number, okay? And then it's about to return and print this stuff out. Okay, so what did it say? And I'm sorry, the red is a little hard to read there, isn't it? I'll see if I can change that later. Okay, so what has it done? It has accepted this input value, okay, and scanf has returned 1. Okay, and actually, there's one other thing I need to do. Let me go back to the code. I forgot one thing. Okay, so again, what is my ampersand my number? Yeah, it's the mailbox number. Okay, and I just added in a line here, I'd like you to please print me the mailbox number of that value. Okay, and actually, let me move this line to up above for reasons that'll become clear in a moment. Okay, and then let me recompile it. And then let's go back here. Oops. Okay, so what did it give me here for the location of that variable, my number? 7FFFFFEFB4. Okay, great. Right? So let's go in memory and actually see what's there. All right, so what was it? 7FFFFFEFB4. Okay, so we're looking at memory starting at address. Oh, and this blue is terrible to read also. Yeah. Okay, I'm going to have to work on the colors because this is kind of hard to see. I think you guys would agree. Yeah. All right. So anyway, it told me the mailbox number. And what I've done with this X32XW thing is basically asked it to show me 32 rows of memory, basically 32 however many bytes that would be, like 128 bytes or whatever. So show me a big pile of memory starting at the mailbox number blah, 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 EFB4. Okay. And what do I see here in EFB4? This is 32 bits worth of stuff. And what do I see there? A big old fat 0. Okay. That should make sense because have I accepted the input from the number yet? No. I've allocated the data, but I haven't actually accepted the number yet. Okay, so let's continue the program. Okay, and then let me look back into memory. Okay, and what do I see in my mailbox now? At that exact same spot. Is that what I'm supposed to see? Bing, 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 bing. Guess what 1832 is in hexadecimal? 728. Okay, so 728 is the encoding of 1832 in hexadecimal, and this thing is going to display everything in hexadecimal because, well, you're big boys, so it's time for hex. You just grew 4 extra fingers. Yeah? No? Bueller? Okay, so does that make sense that there it is in memory? Woohoo! Okay. Also, by the way, what else has changed in memory at that top row? You guys notice anything? What's happened here? It's changed to a 1. What number, what thing was the number 1? Yeah, the value of success 1 happens to be in memory just a couple spots over. Okay, great. Good? Okay, so let's continue. All right, and it's about to print everything back out for us. Okay, wonderful. Now we're going to ask the user for a string. And let's type Wabash always fights, especially if beta pledges have hats. Okay. Yeah. I understand there's been lots of shenanigans in the last week. Huh? I already know too much. There's not a whole lot that goes on in this campus, Patrick, that I don't know. Okay. Let's just say much of what I do know is not fit for streaming out live to the internet. Okay, my Twitch account will probably get shut down like that if I say half of it, right? Okay, so I just accepted this big string, and then the input string was Wabash, and Scanf returned 1. What did I type? Yeah, I typed a really long string, but it truncated it at the space. Okay, and the reason it did that is because scanf, unless you tell it otherwise, is going to truncate the data upon hitting a space or an enter or several other characters. Okay, there's a way to tell it to not do that, which we'll talk about later. But for this instance, notice that it truncated my input data a little bit. Okay. And we'll rerun this, and I'll show you a different way that it truncates it. Okay. All right, so let me quit that. Oh, sorry. There's one other thing I forgot to add into my code, which will be a good thing. What else do I want to know? I also like to know where the string is in memory, right, for comparison's sake. All right, so let me just add that in there so that we get the mailbox number for the string, recompile it, and then let's go and rerun it. Okay, so we already talked about the number part, right? So nothing particularly exciting there, but I do now also have the mailbox number of the string, okay, which started at blah, 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 A0, okay? So let's look at memory at that location. Oops. All right, so what was it? 7 FFFF EFA0. Oh, sorry. I was missing an F. Okay, so Patrick just pointed out, wait a minute, why didn't I put an ampersand in front of my string whereas I did with my number? Okay, the string's name is its own pointer. That's not true with integers, floats, other things, okay? And again, I kind of wish that they had been a bit more consistent with this, where you wanted a location, you put an ampersand in front, and then it was just always the same. That's just not the way that it's defined, and I'm sorry it's confusing. Okay, I didn't make the language. Okay, so strings and arrays, their name is their pointer. And actually, in most cases, if you put the ampersand, it's fine. The compiler will just sort of deal with it because it knows what you mean. But strictly speaking, you don't have to. Okay, so where was my string in memory? What was the starting address of it? Okay, and let's make sure I type this correctly. The string is located at 7FFFFEFA0, and that's what I typed there. Or sorry, here, yeah. I forgot an F the first time. Okay, so we're looking at memory starting at 7FFFFEF0, okay? And what do we see here at that starting address? Yeah, there's a bunch of gobbledygook, okay? And actually, the pair of them, what you're looking at is a memory address, and the way you read this is 7F FFFFEFC0. Okay, what that means we'll talk about later. Okay, but for right now, it's garbage. Okay, now what do we see a little further down? 728 and 01, and those were the values that are 1832 and our success for accepting the number as input. Okay, so those made it good. have we typed in the string yet? No, we're about to, okay? So let's continue running the program. Please type a string. All right, and so let's do Wabash always fights, especially betas, right? Okay, and then it's going to reprint the string to me. Okay, so what happened this time? It cut it off, and let's count how many characters do we have in there. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. That's actually interesting because how many did I allocate for this? I only allocated 16 for it. Okay, so what we just did was technically quite naughty. Okay, and I'll explain why in a moment. What, that we just did something naughty? Oh, yeah, I guess. Well, all right, so where was our string in memory? It was here. Okay, so let's look at what we've done. So that's the starting mailbox of the string, and what do I see here? Okay, what am I looking for? Well, I want to see the string that I just typed in. Okay, where is said string? Well, it starts here. Okay, and remember how are the strings encoded? In C. How is the string encoded? In ASCII. Okay, so what's the capital W in ASCII? Pull up an ASCII table real quick, Patrick. Five eight? I think you're off by a row. Really? You sure it's not 5 7? Uh-huh. Yeah, you might want to go get your eyes checked, bro. All right, 5 7. Okay, so 5 7 is right there, right? This is the least significant two digits of that number, and that's why it appears on the right, even though you think it should be the first thing, okay? All right, then what's the lowercase a? 6 1, B, A. So Waba, SH, capital A is 4 1, lowercase l, and so on. Okay, now, how do I know that I've hit the end of a string? Huh? Yeah, so strings end with an extra character that's just in hex 00. Okay, so not the character 0, but the actual hexadecimal encoding 00. Okay, that's called the null character or the null terminator, and that's what you designate to say, hey, this is where the string should end. Okay, so what's happened here is that our string continues. Okay, and the other thing that we've done is, so let's take a look at this. What was in this memory address? Okay, so this was blah, 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 B4. What did we put there? So the 728, what was that? That's when I typed 1832. That had to go into memory somewhere, and it went into that spot. Okay, after I accepted the string, what happened? Do I see 728 there? No, I actually overwrote part of memory that had data in it. that had my 1832 in it. Okay, so what would have happened if later in our program we had needed to use that number 1832 for something? We'd be screwed because we just overwrote the place in memory that had it. And the reason that happened is because Scanf, we allowed it to give us more data than we allocated space for. Okay, and so what we need to do is, and I'll show you guys how to do this later, is how to tell Scanf, hey, don't give me more than 15 characters or whatever. Okay, so we didn't allocate enough space, and the fact that we got 24 or whatever it was, as opposed to 27 or 35 or whatever, was sort of, I guess, coincidence in this case. But yeah, okay. So that's what I meant when we said we've done something very naughty, is we've overwritten memory that should have been holding, should have been holding an integer's value with string data, and therefore we've destroyed that integer data, and that's bad. Okay. By the way, if I just ran this program, it worked, right? Everything was okay. But what happens if I try to write or read from memory that I'm not allowed to write or read from? Okay. And in this sense, like, did you guys ever talk about memory management in 111 or even 211? I doubt you needed to. Okay. So let's take this mailbox number for a second. Is this actually the mailbox where the string is? Is that literally the spot in memory? If I went into my DRAM and found that spot, is there actually data there? No. Okay. The reason is, well, first off, how big are these memory addresses? Okay. So this 7FFF blah, 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 blah. What kind of number is this? How big is it in bits? Bigger. It's 64 bits. Okay. Memory addresses are 64 bits on this architecture because what kind of processor is it? It's a 64-bit processor. Okay. All right. So let me back up a moment. Let's say that you only use 32 bits to describe memory mailboxes. How many mailboxes do you get if you have 32 bits? And each bit holds, each mailbox holds exactly 1 byte. You only get 4 gigabytes worth of mailboxes. Okay. How much RAM is in most computers nowadays? At least 8 or 16. Okay. The Raspberry Pis are an exception here because they're low power, inexpensive. You know, you're not going to be running Crisis on them. Okay. But the laptops that you guys all have, right, have at minimum 8, probably at minimum 16 gigabytes of RAM. Okay. So if you have 16 gigabytes of RAM, but you only have a 32-bit address space, you can only allocate 4 gigabytes worth of memory. Well, let's say you got 16 gigabytes in your computer and only 32 bits of address space. How much memory can you actually use out of that 16 gigabytes? 4. And the other 12 is just useless. That's bad. Okay. All right. So if you're not going to use 32 bits for the address space, well, what's the next size up? 64 bits. Okay. How much data can you allocate if you have a 64-bit address space? Well, just for the sake of speed of computation, let's use Wolfram Alpha. Okay, so the number of bytes would be this number. Okay, 18.45 exabytes, right? That is a gigantic number. So big, in fact, that like if we, let's say we took that and we divided it by the number of people on the planet, that means that everybody gets 2.37 gigabytes per person, right? That's a lot of data. Yeah. Okay. Okay. So this is a very, very large number. Okay. And in particular, let's take the number 7FFFFFFFF, blah, blah, blah. Okay. How do I convert that to decimal, by the way? Right. So if I wanted to know what is 7FFFFFF, blah, blah, blah in decimal, how do I do that conversion? Well, I could actually do it with Python real quick. Okay. That's a big number, right? How big is that? If I said that that was a number of bytes, what is that? 549 gigabytes? Do I have 549 gigabytes in my Raspberry Pi? Do I have anywhere close to that in any computer that I own? No. 549 gigabytes of RAM? Yeah, no, hard drive space, that's a completely another matter, right? This would be 549 gigabytes of RAM. Okay, so for there to be a mailbox with that actual number on it, I would need to have at minimum that many gigabytes of RAM. Do I have that much RAM? Of course not. Okay, so what does that mean about the number? Is that actually the number of an actual mailbox? No, it is not. It can't be. We don't have nearly that much memory. So what is that number then? It looks to us like it's a mailbox number, right? But is it? Not really. Okay, so what kind of memory are we actually looking at here? Okay. This is called virtual memory. You guys ever heard of this before? Yeah, virtual RAM. Yeah, but not necessarily VRAM, because sometimes that gets used to designate the video card's memory rather than, say, RAM, regular RAM. Okay. Okay, so virtual memory is something that the operating system does for us, right? When I run a program or something, I'm essentially asking the operating system, hey, can you allocate me some memory? And the operating system's like, yeah, sure, here you go, bro. Okay. And would it be convenient for me if that memory was all in one contiguous block, right? Even if I need, like, say, a gigabyte worth of it, even though there may not be a fully contiguous block actually free in physical memory. Okay, so what the operating system does is it says, okay, here's your block of virtual memory, and then it keeps track of translating, okay, if I access this virtual address, what physical address is it actually tied to? So that the program doesn't have to deal with any of that crap. Okay, so these numbers that you're looking at are basically fake, is what I'm trying to say. Okay, that's not actually where they are in memory, but we can pretend that they are for the purposes of our sanity. Okay. Yeah, is that okay? All right. So we've got some input. That's all fun. And I guess maybe one other thing we can do today is, well, let me make a new folder. Oops. Our favorite topic ever, right? Let's talk some recursion, shall we? All right, so let me close all of these guys. And let's make a new file. Okay, so what's everybody's favorite example of having to use recursion? Pray tell. The Fibonacci numbers. Okay, that'll be your homework assignment. So what's your next favorite example of recursion? The factorial. Good. Okay, so what is the factorial defined as? What's 0 factorial and 1 factorial defined to be?
It's like every number, it's like factorial of a number, and that number times every number leading up to it.
Starting with 1, yeah. Right? So 1 factorial is 1. 0 factorial, for technical reasons, is defined to be 1. 2 factorial is 1 times 2, which is 2. 3 factorial is 3 times 2 times 1, which is 6. 4 factorial is 4 times 3 times 2 times 1, which happens to be 24, and so on. Okay, so the recursive relationship here, so let me do this, and let me define a function that's going to compute these. Okay, and this is going to compute n factorial equals n times n minus 1 factorial. Okay, so that's the recursive relationship between that defines this thing. So if I want to compute 6 factorial, what is it? It'd be 6 times 5 times 4 times 3 times 2 times 1. But what is 6, or what is 5 times 4 times 3 times 2 times 1? That's 5 factorial, right? So 6 factorial is really 6 times 5 factorial. What's 5 factorial? 5 times 4 factorial, and so on. Okay, so what's our base case, right? So if the number that comes in is less than or equal to 0, or sorry, 1, what should I return? Right. Otherwise, what should I return? Okay, n times fact of n minus 1. Okay, does that make sense? So what are the base cases for the factorial? 0 factorial, 1 factorial, those are both defined to be 1. Okay, and so if I call this function with, say, the value 5, what is it? Is 5 less than or equal to 1? No, so I go to my else case, and I'm going to return 5 times whatever the factorial of 4 is. The function runs again, and so on until we get down to 1. Okay, so does that make sense? All right. Okay, so you see, why is this a recursive function? What makes it recursive? Hang on a second, Artie. How do I know this is recursive? Exactly. The function calls itself. It's self-referential. That's what recursion means. Yeah, Artie. No, it's this function that I'm defining. We have right here. So okay, I see what you mean. Let me do this. So you can do this in 2 steps. Like so, right? Is that kind of what you meant? Yeah. So the equation is right here. The answer to the question, what is n factorial, is whatever n is times whatever n minus 1 factorial is. And this is recursive because the function fact, so I just called it fact for short, right? The function fact is calling the function fact, right? So it calls itself self-referential, hence recursion. Okay, yes? No. Okay, good. So I have made this function so that it accepts an integer and returns an integer, but I haven't actually done anything with it yet. Okay, so what should I do to run this thing? Well, let's accept some data from the user. How about that? Oops. Okay, so let's accept an input value from our user, shall we? Okay, and so how do we accept input values? Yeah, that sounds like a good idea. Okay, tell them please type something. Let's scanf. Well, what kind of data do we want? We want an integer. And where are we going to put it in memory? And ampersand input val, right? That mailbox. Okay, I've got a bunch of red junk going on up here, so let's see what the problem is. Oops. This needs to go 1 line up. Oops. Okay, so what was it? There we go. Okay, so sorry. All right, so get some input, and then I need to, let's do int fact value equals fact of input val. Okay, so that's going to actually pass the input value over to the function. The function will do its thing and compute the factorial and return the answer back to me. And then I'd like to print that, right? So how could I print that? Let's do something like printf percent I factorial is percent I. And what was the input value? And what was the number that we got out? Fact value. Okay, so this will say, like, if I give this 5, it'll say 5 factorial is blah. Okay, good. And then what do I need to return to the operating system? So it's happy. Okay, good. All right, so let me change directory to recursion and gcc recursion.c, recursion. Oops. Okay. All right, please type an integer, 5. 5 factorial is 120. Is that correct? Yes. Okay. What about something bigger? Okay. So what happened? It's too big. It overflowed. Okay. Yeah, the 1832 factorial is too large to fit as a 32-bit integer. And so it overflowed, and that's why it looks like it's giving us 0, even though the answer is clearly not 0. Okay. Okay. So with the factorials, is this recursive method of computing it particularly efficient? I mean, it works, right? Is this the most efficient way to compute a factorial? What would be a more efficient way besides the recursive definition? Well, could we do a loop? Yeah. Okay. And in fact, what's the difference between computing a factorial with a loop and computing the triangular numbers with a loop? How did you compute the triangular numbers? So what's the fifth triangular number? Okay, and how did you get 15? 5 plus 4 plus 3 plus 2 plus 1. What's factorial? The same thing, but you're multiplying instead of adding. Right? So it'd be 5 times 4 times 3 times 2 times 1. Okay, or equivalently 1 times 2 times 3 times 4. Right? You can do the do you want to go top down or bottom up? That doesn't really matter. Okay, but would you guys agree that a loop is probably way more efficient for that process? Okay, but doing it with a factorial, or doing it recursively, even though it's not the most efficient way of defining it, it does sort of allow us to illustrate the concept of recursion. Okay, okay, so this was our second favorite example of recursive functions. What's our first favorite example? The Fibonacci's. Okay, so what are the Fibonacci numbers? Okay, how are they defined? Well, let's just go to the bastion of all knowledge of Western civilization. Right, which is to say Wikipedia. Okay, so I personally start with the 1, not with the 0. It doesn't really matter, but let's just declare that for the purposes of all of our collective sanity, the first Fibonacci number is 1. The second Fibonacci number is 1. The third is 2, and so on. Okay, how do I generate the next number in the list? I add the 2 previous. So the fourth Fibonacci number is 3. How did I get 3? I added 2 plus 1. 5 is 3 plus 2. 8 is 5 plus 3. 13 is 8 plus 5, and so on. Okay, so each number, Fibonacci number, is the sum of the 2 previous numbers. This also means how many base cases do I have to have? 2. What's the first Fibonacci number? 1. And what's the second Fibonacci number? 1. Okay, and that is just will be our definition for this purpose. Okay, now this is a very important sequence in a number of interesting ways mathematically. Okay, there's all sorts of cool properties that this thing has, and you can find it in nature and in music and in the human body, and it originally had to do with Fibonacci, who basically made up a problem involving breeding rabbits, and this sequence popped out. So it's kind of interesting, but it's a good example of a recursive function. Okay, it's also a recursive function that it's so widely known that when you guys program this and you ask it, hey, what's the 10th Fibonacci number? If you don't get, what is it, 55? Right, you know instantly that something's messed up because like this sequence is so famous. Okay, so that will be one of your fun and exciting assignments, is to define a thing that will do it both recursively and iteratively. Which one do you think, is more efficient? Yeah, iterative definitely, but the recursion is still a good example of recursion. Okay. Okay, so let's just recap what we did today briefly. The TLDRs were, we talked about input handling with Scanf, okay, and a little bit more about pointers, although we'll talk tons more about them later, okay. So we've got input handling with Scanf, and then also just briefly the recursive stuff. Okay, good? All right, see you guys later.